Hey, welcome to episode 4. Today we're talking about if statements, or what I would otherwise call conditional statements. Right. So, previous weeks we were able to look at lists. Right. We were able to look at basics of Python, like variables. Our ability to use variables. And all of those. Now this is week 4. Right. We are building up on everything we've learned, and we want to add a very very important tool to our arsenal. Right. Not actually gone as arsenal. I mean arsenal. Arsenal, you mean your weaponry, right? Don't mind me. Okay, so if statements are a very very powerful thing to have, and to also know, because they help you to be able to dictate how your program is going to flow. Because of course in this life it's not everything that is straight, right? Some things are actually not straight. When I mean straight, like they don't go from head to toe without some conditions attached, right? There are a few case scenarios where we just tell the computer, okay, just do this. So the program will run from head to, and will not have to have any branching conditions. But in most cases, there are cases where even in real life, right, where we have conditions. For example, now we want to register voters, right? But then we can't just register anybody. We need someone who is 18 and above, right? So we'd have to take the age of the person, see if the person is eligible to vote. That is, if the person is 18 years or above. You can't just go ahead and register a 1 year old baby, right? So that's it. That's what we are going to do today. We're going to see how to bring in all of those conditions in, right? For example, you send someone to the market to get you this brand, then you can say, okay, so get me this brand. If this brand is not available, come back. Or if this brand is not available, get me this. Or maybe you are a person that has so many choices, if this brand is not available, get me this brand. If this brand is not available, get me this brand. If this brand is not available, come back. So we'll see all of those guys. But before we head into doing that, I'll just take us to the whiteboard. Right. So first of all, let's assume we have okay. So before I do this, let me bring in the circle. Let's assume we have the stats. This is where everything starts, right? Of course. So I'm going to now have a first task. Let's say our task, I'm just going to limit this to what we're supposed to do. So let's assume our first task is just to collect persons each, right? So we'll just have task one, collect each, right? Or get each or anything. So that's the task one we want to do. But I don't think we really ask. I think we use birth certificates, right? A document that shows your date of birth. Because if you ask anybody, they can just tell you any false age. But now we ask for your birth certificate so that we can validate that you're so years old, right? So you collect the age. Now what do you do from there? Let's link these guys up with arrows. So what do you do from there? I can come back here and okay, add like a decision now to decide. And this is where I verify everything. We use this diamond symbol. It's not perfectly like a diamond anyway. But then, you know, it's a diamond either ways. So here we just check, use the simple check if age is greater or equal to 18, which by the way you can also see if age is greater than 18. This greater than or equal to, this is how we write greater than or equal to in Python. Of course, I will discuss more about that as we continue to go. This is how we write greater than or equal to. So we get an arrow, we fetch this guy, we link this guy to this guy. Let me see. Okay, stay here. Why are you not staying there? Okay, so let me do this. Don't mind my diagram, please. Don't mind my diagram. Okay, so let's assume we have this, right? So it checks if the age is equal to 18. Why we have this is because this allows us to branch, right? I'm just trying to show you in a diagrammatic way. I'm not sure if diagram is correct, but just trying to use diagrams now to show you, you know, that what is actually happening when you use if statements, right? So we try to check that this is the condition we pass now. This is the conditional test, right? If age is greater or equal to 18, what happens, right? So we can decide now to have other tasks. So if the age is actually greater than 18, let's say if it's true, let's say this is true. Let me add an arrow here. let's say this is true, right? So what do we do here? We register the person, right? So let me say condition is true, right? Condition is true. Now, if the condition is false, we can decide to do something, right? We can decide to, okay, so condition is false. We can decide to bring in another task here, you know, to we can either make it just go directly. Let me do this. Let me just make this go directly. Okay, first of all, before I do that, let me add the end here. Because once the registration is done, you do what? You end, right? This is the end. We actually call this kind of diagram a flow chart, right? And as a programmer, which you are now, or a prospective programmer, this is where everything begins. Everything begins from the drawing board, right? You are expected. Some of us just make the mistake of mounting up and start coding. You're supposed to have this. You draw, have a rough sketch of everything that you're supposed to do, you know, and then when you're done, you just move ahead to execute. So this is our plan now. This is like our architectural design. So what do we do? I just have an arrow here. I will just draw from this guy to this guy. Perfect. Now, if this organ now decides that, okay, you know what, this condition is false, what do we do? We can make this come from here and to this place directly. Can make this come to this guy directly here. So what do I do? Let me just bring this here, right? Beautiful. So now you can see that even though this is not the most perfect of designs, but let me try this. Let me just expand this. So yeah. So now you can see that when the condition is true, what does it do? It passes here. But here is when the condition is false, right? Condition is false. So condition is true, it goes down. Condition is false, it still goes down, but it skips the registration place. And it tells it end. If you like, you can add another task here, right? Let me make call this task two, right? We call this task two. And then if you like, you can come and add another task here and then tell the person, okay, sorry, you're not eligible to vote, right? So this is exactly what happens in a diagrammatic way when we're using an if statement, right? We try to check a condition. Okay, if the condition is met, do this. If the condition is not met, you can just, just keep or do this instead. So we're going to see how to do this, how to go about this when we just need to check, just one condition, when we need to add an else statement, when we just need to check two conditions. If it is not this, then this. We also check then, when you have more than two conditions, how you can bring them in. All of those we're going to look at them right today. So fasten your seatbelts and let's go on. So today we're actually going to be looking at how to use Jupyter Lab. So this is an example of a Jupyter Lab. So I'm just going to go ahead, close this window, then start this here. So we're going to be starting a new notebook. I'm going to share a video tutorial. Just check it anywhere. You should see a link in the description that I'm going to create a tutorial on how to use this, how to install, and how to also use, right? So the advantage of having an offline notebook like this is that you don't need internet connection. As you can see, I'm not even connected to the internet. As you can see, right? My Wi-Fi is even off, but I'm still working, right? That's the beauty. So sometimes we have network issues, and so the last thing you want is for network issues to mess up your day, right? So we do not want network issues to stop us from carrying out our tasks. So you have this kept in your computer, right? So first things first, you can rename your notebook here. Let me do that. Rename notebook. This is week 4. Correct. Now, all that is left is for us to start writing our code. I'm going to, that example you saw on the diagram now, I'm going to try to bring it up. So let's say we have age, and let's say our age is equal to 20, right? Then we can come here and say if age is greater or equal to 18, because 18 is our pass, right? If age is greater or equal to 18, what should you do, right? That's what ideally we're supposed to do. So we you add the column symbol. This looks close to the for loop we did last week, right? So this entire thing now here is actually what we call the conditional test, and I'm going to show you that we're going to see all of those. So here Python tries to check if age here is greater than 18. Eh? It checks, it tries to, okay, age is greater than 18. Is this true or false? If this is true, then it executes whatever you have here, you know, after the block of codes, right? Else it will just skip, right? So what do we want to print? You are eligible to vote. Now let's try this out. You see, it tells us that you are eligible to vote, right? So now, if what if the person's age is now 17? Nothing happens, right? It does not tell the person anything, and that's a classical example of what we have here on our whiteboard, right? Because we just told the computer once it's greater than 18, just end, you know. But we can actually add another condition here, right? That not actually condition, another task, like I said, that will tell the person, if your age is not, then it will tell the person, it will give the person a feedback. Because I actually feel it's not a great way to not give somebody, a feedback on something. So here we can just bring in an else statement. So if the condition is not satisfied, that is what the else does. If the condition is not satisfied, or if the conditions are not satisfied, then it will do this. So what will it do? Just tell the person print. We'll just do this. You are not eligible. You are not eligible to vote at this time. Okay, so let's run this. Now you can see this is fair enough, right? So you have feedback for both people who are eligible to vote now, right? You can also add other statements, just like we saw in the for loop. You can add here proceed to registration stand, right? Let's assume this person now, that this code now is just to help us filter out people who are not eligible to vote before they even come to the registration stand, right? But before they redirect us. So here you're not eligible to vote at this time, right? You can also add another statement to just tell the person, okay, so try again. It's also year's time, right? You can decide to just do a little calculation here, and then try to calculate how far is his age from 18 years old, right? So if I want to, this is just extra. I'm not saying you have to do this. I can just come back here and say, please try again um, in how many years time? Let's do this. F formatted, right? In let's do how many years time now? That will be the age of the 18 minus the age of the person, right? Whatever the age of the person is, right? So 18 minus the age. So it's not just variables that you enter here. You can enter even calculations, right? So try again after this. Yes. So let's try this. So you can see you're not eligible. So let's put these years in brackets instead. You can see for 1 year now, we're having yes, 1 years, and that's actually not a great way to put it, right? So let's do this. And then let's run this. Of course, you're not eligible to vote at this time. Please try again in 1 year or 1 year. So what if the person's age is 10? Please try again in what, in 8 years. So you can see we're just using whatever we knew previously, right? To be able to sort out, to be able to solve this problem. And you can also come up with your own way of doing this, right? Think about other examples, think about any other thing that you can use numbers to actually check for conditions, right? So that is what the if, now we've seen only the if statement. We've seen how to add the else statement. Now, what is left for us to learn further is how to be able to handle a case where we have so many conditions, right? And we have a case that solves that for us. So now, I want us to take example two. Example two is supposing we're trying to check the list of students, in a class, or maybe we have some invitees for a particular program, want to check the list of the people whom we have invited, right? And then so we have this program where you come in, tell us your name, and then the program checks if your name is among the name of the invited guests, right? So let's create a list called guests and collect a list of people. Have Joseph. Let's have Jacob. Let's have Ahmed. Let's have Musa. Okay, so we have all of these names. Now, it's always a good way to print and see what you have, right? Of course. So now, let's assume this guest now came and then he told us that his name is what is Joseph. If he tells us that his name is Joseph, right? We want to check if Joseph is in that list, right? So we can try this. We can try if guest in guests, a guest. So this guest now is the name of Joseph. We're trying to say if Joseph is in guest. So in Python, you don't put the is in together. So here we're trying to check in. So once you use the in operator tries to check if a value is in an iterable. Iterable is like a list, like a tuple, like a set, right? So it tries to check. So it will pick the value of guest, which is Joseph, and check if the value exists in an iterable, like a list, like I said earlier, right? A list of, you know, any other thing you have that Python can easily iterate in, right? So now, if guest is in guests, what happens? We add our column. We are going to check print what access granted, right? Access granted, right? You can also add another print statement here. Hey, the name of the person, right? That is guest. Welcome to the party. Oops. Party, yeah. So we have that. Now let me add my F here so that it will recognize this as a variable. Run this guy. Access granted. Hey Joseph, welcome to the party. Nice. Now let's assume you enter a name here. Joshua. Of course, nothing happens. Now that makes us understand the importance of having that little else statement here, right? So the else statement is actually having the same is in the same level with the if, right? Mind you, you cannot have an else without an if. You cannot start with an else statement. Right? Like I told us, the else is what happens when every other condition fails. So you don't have to add any other condition, right? So here in this else statement, we're just going to add print what access denied, so that people have an instant feedback. You know, access denied, of course. So depending on the name of the person, right? But here is a funny thing, which I want us to take this to another level. If we have something like Joseph here, uh, let's have let's try Musa. Beautiful. So I'm just going to copy this. I want us to upgrade this code a little bit, right? Now you notice something that anybody here that is coming, right? Their names, we already wrote their names in a proper way, in an ideal way, that is in a title casing, right? But what if somebody's coming and then their names, they decided to give us this? Let me run this. You can see Musa ran. It means Musa has access because actually his name is in the guest list, right? So here you can see access denied because Python does not Musa and this Musa are not the same title difference. This one, and the only difference is just this, letter M. So Python does not see them as the same. They are never the same. So we're going to see more of that as we continue to go. So what is the difference is that this one is in a title case, while this one is in a what? A lower case. But surely there's something we can do to this. So we can all convert everything to lowercase, right? Starting with the list first, we can create a new list, right? We can let me call this guests lower, that is guests that are in lowercase now. I can use my list comprehension to create another list, a copy of this list, but this time around with lowercase, right? So I can say this is like guest dot lower. You can call this anything. You can x or name dot lower, anything you want to. Guest dot lower for guest and for guest rather one guest for guest in guests. Beautiful. So for this is a for loop now. For each guest, you know, in guests, it will take the guest here and return it as a dot lower file. So if you've not, if this is a bit confusing to you, you can refer back to our previous week's video where we spoke about working with lists, and then I believe you will have clarity. So first of all, we have created this list, right? So let's run this. Let's try to print our guest list. Let's try. Oh, guest lower rather. Meanwhile, if you like food like now you can see our guest dot lower now has everything here with lowercase. So I was trying to say if you like food like you could actually use a restaurant example. Instead of this guest, you have a menu, right? So if the customer orders for this, you tell them we don't have this, or this is not available at the moment, right? That's also another. You can use the conditional check for that, right? So now we have this. We have seen how our access has been denied still, right? Why is because we've not done what we're supposed to do. So we want to allow the users a bit room for errors, right? So we can come here, we can see if guest instead of here we can instead of having just the guest here, we can just add dot lower here, right? So we're trying to tell Python that whatever the guest enters, lower it first before you check if it exists in the guest. And then this one we have to modify it to what? To guest lower because that's the list now that we're trying to use. So what we are trying to do now is we are lowering this. And we're also what? Lowering what do you call it? We're also lowering the this list, right? Because that's what is going to be here. When you is the lower version of every element here. I mean the dot lower. When I mean lower, I mean every name in lowercase, right? So now when we do this, what happens? We can see that Musa has been granted access. And why did we have to add dot lower here? When Musa here is already in lowercase, it's because Musa here can still come and say, "Omo, my name today now capital letters. I want you spell am." So now it will still grant Musa access. Beautiful. But then the problem now is that if Musa enters his name now in small letters, according to our code, it will print Musa in small letter, and we want to be professional people. So we can still find where this guest is, then put dot title here, right? So that whichever way Musa enters it, now what happens? Musa is still printed. You can see it's printed in a title casing. So why are we going through the stress of doing this? Is because the people who are going to use your code are always you can anticipate errors from them, and you don't want them to just you don't want your app to be very very strict that because of little things like case issues your code is breaking, right? You don't want your code to break like that. So this is the original code you would have run, but I just took my time to just show you some things from what we've learned so far that we can actually build a smart system with just the previous week's knowledge that we've learned. And this is a smart system that will allow the user to enter his name anyhow. In fact, if they want to enter it like this, Musa, anyhow they enter it, will still greet them, welcome Musa, and it will still grant them access, right? So this is of course we can do better next time as we continue to learn. We'll continue to be adding tools to what we know already, right? So do me a favor, look for any example. Use a restaurant example. If you're a makeup artist, use the tool. If you are an engineer, use the engineering toolbox, you know, as an example to just try and then check this guy and then see if what I'm saying is working. Try another example. Don't just follow my examples blindly. Try your own example at this particular moment. So pause this video at this moment and try your example. So the third example I'm going to give you is one that is the first example that we have here. So let's create a list called cars, right? Where we have an Audi, we have BMW, we have a Toyota, right? We have a Honda. Yeah, so we have all of this. Now let me print my cars and see. Of course, my cars work. So you remember the for loop for car in cars? Do what we print car. Of course, if you have problems with if you have problems with for loops, please go back, refer back to our previous video, and yet to lower this part. All right, now. So we run this. You can see it printed everything. Audi, BMW, Toyota. But now, I think we have a problem. The problem now is that Audi is in smaller case. Everything is in smaller case, but we want to make this more professional, right? So we want to title. Let's try a dot title to see, so that every first letter will be a capital, letter. So we run this here. Now you can see Audi is in capital, Toyota, Honda, even BMW. But this is not a right expression for BMW because BMW is actually an acronym, right? So it is supposed to be in capital letters. So we can actually do something, right? We can bring in the if conditions now. Can bring in the if the name of the car, that is for cars in cars, if the car is equal to BMW, what do you do? Then this time around, I wanted to print the car, but in uppercase, right? Car dot upper. So we want to tell it else now. So I'll just shift this guy in using my tab key. So this stays in the else block, right? So if the car is equal to BMW, it is only BMW that we are, that we are considering at this particular juncture. It's only BMW that we are considering. So if the car is equal to BMW, it, it changes this to an uppercase. Else, it will leave it as dot title. That's the proper way to write it. So now you can see. So right now we have revised almost everything we've learned for the past 3 weeks. Right? I've been trying to see for the past three episodes, if you want. So we've been trying to see how the things we've learned, we have not forgotten them in the past. We're still bringing them back because we're learning in stages, and you need everything from the things you learned in the first class. You need every knowledge, right, to be able to excel in this particular class. So we've been able to look at three examples where these if statements can become very, very powerful, right? So all that remains is now let's go to our book, add some very, very good knowledge from our book, right? Why do we need a book? It's because if this was an ordinary video tutorial, I would just stop here. And I believe you have a very, very good understanding of if statements and I'll pass, but we need to come through books. What books do to us is that they give us this kind of special knowledge. They give us extra knowledge that we would otherwise not see in normal tutorials. That's why you see my tutorials are getting are longer than normal tutorials, right? Because we use books. Books will tell us a lot. They'll give us exercises. You just learn a lot from books than you get from normal YouTube tutorials. Now, having said that, let's go over to our book. Now, from this, we've seen what if statements are, and of course, there's no better way to start with than the last example we just did, right? So this is just showing us this is what we can be able to do after this class, right? So of course, I know you know how to do this one now. So I know you must be proud of yourself. Now, what is left? Sorry, rather, what is next is we check in the conditional test, right? And this is very, very powerful, right? We started seeing conditional tests. Now let's head over to our code rather. Now for conditional tests, we're going to take a step backward now. See how is Python able to carry out all of this. So what Python does is that first, before this if even happens, right, it takes the age, this condition, it tests this condition. We call this conditional test. It takes this condition, it it how do I put it now? It evaluates the condition. Now when it evaluates the condition, this age now is greater or equal to 18, right? So it checks if the age is greater or equal to 18. The age you enter is what is 10. So age is greater or equal to 18. What happens? It runs this. So it will convert this to either true or false. Because if you have conditions, the conditions must either be true or false. The two conditions can it's not possible that you have a condition being neither true or false, or both true and false at the same time. No, the condition is either true or false. That's how Python thinks, right? So it takes this guy and then it evaluates it and returns either a true or a false. Then if statement can now carry it and then work with it. To prove that to you, erase this now and put true here. Just try it as an exercise and then run. You see that irrespective of the age you enter, irrespective of the age, even if it's 100, to still tell the person what you're eligible to vote, right? If you enter one, it will still tell the person you're eligible to vote because you said if true. Python already thinks this is true, so it will always carry it out, right? True is a Boolean operation. We'll look at it later on. Now, if you enter this false, even if the person is 1,000 years old, 1,000 is supposed to be eligible to vote, right? But that's actually not a real age. But I mean, to tell the person that you're not eligible to vote, and you can even see our example. We have minus 982. That's crazy, right? So what Python does is that it checks if the condition is true or false. So this here, what you are seeing here, this guy here is a conditional test to check whether this name is in this list. If this name is in this list, it returns a true or a false. Then Python can now use it with the if statement to carry out what you're doing. So we are taking a step backward to understand how the if statement is reasoning, right? Because the more you understand how the Python interpreter thinks, the better you are at being able to use it to manipulate it to carry out, so those tasks that you wanted to carry out. So let's see this. Let's return this back to base. Yeah, Control Z. It worked. So now let's come back here. Let's try this out. Let's see our age now. It's equal to 20. So let's do this print age. Is age greater than 20? Can 20 be greater than 20? No. 20 cannot be greater than 20, right? Okay, so let me try 25 now. What happens? False, right? I don't even need this print statement, but you can add it, right? So age is greater than 25 is false because this age now is what is actually 20 years old. 20 years, right? Right. So 20 is never greater than 25, right? So let me make this. This is the greater than symbol actually in Python, right? What of the less than operation? We run this as the less than. Of course, this is true because this is 20. So 20 is less than 25, right? So this is true. What if we want to use less than or equal to? This is less than or equal to, right? It's still less than or equal to. Less than or equal to is actually two conditions there, right? Joined together by or. So is either is less than or is equal to. If either of them um is met, if either of the conditions is met, then Python returns, a true. So here the 20 is not equal to 25, but 20 is less than 25. That is why this will still return it true, right? What if I put greater than or equal to? Have this. This is false because both conditions are even false. The greater than 20 is not greater than 25. 20 is not greater than. Um, it's not equal to 25. But if I bring in 20 here, this is going to be true because meanwhile 20 is not greater than 20, but 20 is equal to 20. Right. So those are operations. Now let's see the equality operations. Equality, the ones that test if things are equal. So you can use the double equal to. That's the one that tries to compare both sides and see if they are equal. This, don't confuse it with this one. This one is just an assignment operator, right? This guy here. So what it does is that it assigns a value to a variable. So it takes 20, and it assigns 20 to age, right? So that is what it does. The one you once you have one equal to, it's an assignment that you're doing. If you have double equal to, it means you're trying to check left, and right hand side. You're trying to check and make sure that they are the same. You're trying to evaluate, right? So let's run this. This will be true because age is 20, and we're trying to say age is equal to 20, right? We're trying to say 20 is equal. This is equivalent to saying 20 is equal to 20, right? So now, if I say 20 is not equal to 20 and I run this is going to be false because this is not equal to. Okay, this is actually how we write not equal to, right? So, what if I say not equal to 21? Correct, because of course, age is not equal to 21. Okay. So I think we've done a lot of examples. We've seen these guys. So these are basic comparison operators. We've seen the less than, equal to, greater than, equal to. We've seen the equal to. We've seen the not equal to. Right. Now let's look at when elements are contained in in a list. Right. So we also looked at this. Um, we said if guest, let me use this simple example. If guest is in guests, so let's print our guest list. Beautiful. So let's assume now. Let's see what is happening when we tell Python to check if Joseph, you know, is in. Because for list you cannot use something like equal to, So you have to use this. If this in guest, let's see what it returns true. Because it actually checked the guest list and then it saw that Joseph was there, so it is returning true. So the condition will now, the if condition, whatever statements that you have after the if condition will now be carried out, right? Now, what if we try small letter J like we saw? It returns false because it searched and then it did not find any Joseph that started with small letter J or any Joseph that was in lowercase, right? So that's how Python thinks. And so it is very, very important that you understand that, right? Okay. We'll also be seeing other operations. There are times where you might want to join one or two conditions together, right? Um, Maybe let's say name of guest. Let's say guest is equal to 10. Sorry, guest is equals to Joseph, you know, and then the age of Joseph, that is the age of the guest, right? Let's say is equal to 25, right? So we can actually check to see, we can set to check age of, let's say, guest. First condition, we can check guest in guest. This is one condition now, right? This is one condition now. If I run this, this is true. Now, what if I want to check and I want to be strict? I want to check that your name is there and then you're greater than 18 years old, right? Before you're allowed into my party, right? So guest, and we're going to we can use the and. So we have the and the or. So two of them. We're going to see how to use them. So the and now, I'm very, very strict. So I'll come and say and age is greater than or equal to 18. So this still returns true. Why? Because guest is actually in guest and then the age is actually also greater than or equal to 18. Right. But it's best practice to for you to uh, put these guys in brackets because you can have as many ands as possible. Right. So it's best practice to put them in brackets so that it will not confuse you, and at some point in time it might not also confuse Python. It might not confuse Python, but when you're writing codes and then the codes get messy or lengthy, it might confuse you, right? So let's run this. We have true, right? Now, what if I change this age to 17 to see false? Because even though this guy right here is true, right? The and condition, the and condition, how do I put this better? It it demands that both conditions must be true before it is evaluated to true, right? So let's add, let's do something. Okay, meanwhile I'll still drop another tutorial. Just check out on the channel on how to use this efficiently, how to add codes, how to add code cells above and below, how to run your codes, and I'll just tell you a lot how to use Jupyter Lab. Inside Jupyter Lab, I'll give you like a 10-minute tutorial on how to use Jupyter Lab. So check out our channel for that. And I'll also drop the link in the description if you're just watching the video now. Okay, so um, like I said, okay, so let's see the anatomy of this and or statements. Let's take a step backward and see what they do, right? So let's do this. Print false. Let's do like this true. So this true, you can see I'm deliberate about how I write it. It's starting with capital letters, right? It's starting with capital letter T, or let me say it's in title case. I'm very, very deliberate and particular about how it is, right? So um, I can say print true and true. That is number one. So true and true is going to be true because once both of the conditions are true, then it's true. But if even if it's one of them that is false, right? I'm just trying to show us this. I know we learned this in basic math, and for some of us that went through computer science or math, this is you must have learned this already at an advanced level. But for everyone else, if you've gone through, even if it's at least a secondary school level math class, then you should have learned this small computer logic, right? So we have this true, you can call them ones and zeros, right? One for true, zero for false. So true and true give us what? True. Let's try true and false, right? The false also can start with capital F. Let's try false and true. Let's just try different scenarios. And what if we have false and false, right? Or we have false and false. Let's run these guys. Now you can see that true and true is only true for this particular condition when we are true and true. Every other case, once one of these or either of the conditions is false, Python automatically flags our guy down, flags it out as false rather. So what if I want to copy this, then have this here, or 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 have this, or great. So I have, instead of using and, I'm using an or condition, right? So what is the or condition saying? The or condition takes two. Sorry, the or statement takes two conditions and evaluates them and see. Okay, so if both of them are true, it returns it true. If even one of them is true, it still returns it true. It only returns a false when all of them are false. All of the options are false. So here you can see when we are true or true, it returns the true. True or false, it returns the true. False or true because we have one true. Even if we have only one true, it returns a true. Then it's only false when we have one false, right? Okay. It looks almost like the opposite of this guy, but they are not actually opposite because if you consider here true and true is true, and here true and true or true is also true. So don't say it's opposite. Yeah. So let's go back to that example we're working on. So this is using and. So what if we now decided to soften up? We said, okay, so it's either your name is in the guest list or you're above 18 years before you're allowed into the party. And then let's say we want to use something like your national ID card, your national your passport, any other thing to verify your age, right? So we run this guy now. This returns it true. Why? Because even though this person is not greater than 18 years, his name is in the guest list, right? Very good. So what if the person is greater than 25 and then his name here is just a small letter G? This still returns true. You can still allow the person in. Why? Because though his name is not in the list, right? His age is above 18 years, right? So if you want, you can just bring in your small if now, just if here. If this, and just bring it here. Then print, and I'll look at that. Print access what? Granted. Beautiful. Access granted. So this works. Access granted. So you can see how we have now gone back. What we are trying to do is that we're trying to take a step backward or steps backward to try to see how Python thinks so that we can take advantage of how it thinks, to be able to achieve our aim and objectives, right? Beautiful. So we've actually checked this condition, right? Where we assigned a car to BMW, and then we are trying to check is BMW equal to BMW, because at this particular point now, it's you that is seeing it as car, but Python is actually seeing it as BMW, this value here. So it's trying to check is BMW equal to BMW is true. But then this is car is Audi. So what Python is seeing here is Audi. So you're trying to say is Audi equal to BMW. It's a lie. So Python returns false, right? That's what our book is trying to teach us, right? Even these two are not the same. That's why Python will return what? False here. Because this is capital letter A and this is small letter A. But there is a work around it, right? You can just apply a dot lower to this car, like they did here, right? And then it will be equal to Audi, right? Beautiful. Um, so we are checking for inequality. We did this, right? If this is not equal to this, because we did that, you can check out the example. Then numerical comparison, we saw the equal to symbol, right? Very, very good, very, very powerful. This not equal to also works. We actually also saw it. So you can look at the examples pretty well and then try them out. Of course, that's a better way to learn. Now you can see the less than, equal to, greater than or equal to, and all of them. So checking for multiple conditions using and or, we've also seen that. So we've actually covered some stuff. So using or to check, we've also seen how to use or to check multiple conditions, right? So checking whether a value is in a list, we've actually also done that. So you can actually also look at their examples, right? Before you look at the examples, make sure you read the little text that is here. They try to explain to you what the example is, why they are thinking in that way, and then it's very, very good that you augment whatever it is that you're learning with books, like I've said already. Okay, so checking whether a value is not in a list, right? If a value is not in a list, we use the operation not in. That is the difference. Just adding this not before the in, right? Don't come and write in not, right? It's going to be not in. Um, so here, what if we want to change the sequence of our program and then want to say if value, um, if okay, let's say guest, let's give our guest a name, Joshua, right? So we can come back here and say, instead of saying if Joshua is in, we can say if guest name, that is Joshua, right? Not in the list guests. What do we do? We print access denied. So you can see that's another way of writing the program. So I told you there is more than one way you can write that program. Right? This particular code we wrote here, you can either invert it here, right? You do the not in, and then this will now be denied and this will be granted, right? Depends on how you want to do it, right? So try that out and see if it works. So you can see access denied. Why? Because the guest name, this Joshua, is not in the list, right? But what if I try Joseph or even Musa? Now I can add the else condition. It means it has allowed the person to pass, so I can add the else condition now, right? Beautiful. So um I can just go back to what we had. So this is how to check if the guest is not in. And their own example is a very, very good use case. They're trying to check, okay, so for let's assume for a particular website or for a particular website we have these usernames that are banned. Right. I think sometimes they used to um ban you from Twitter, right? I'm not a very, very good fan of Twitter, but I also know they used to even Facebook used to suspend your account, right? So while you're suspended, imagine that they have a list suspended users. So your username is here. So once you're trying to log in with your username or your phone number, right? Once you're trying to log in, it will check if it is here. It will tell you your account has been suspended. So that's the thinking. That's how they think. So the more you continue to go with me on this journey, you continue to understand why your applications act the way they act, why certain websites act the way they act, right? So now Boolean expressions are the true and the false, just like I spoke to you about them. They are true and false, and they are like one and zero. They are like on and off. They are like male and female. Of course, in Nigeria we still do only male and female. They are like as mentioned on and off. So just two conditions. If it's not this, then it's this, right? So that those are Boolean operations, and they are like values. They carry values. True represents one, false represents zero. Okay, so if you think I was joking, okay, I know you don't think I was joking. So let's do int true. Let's convert it to an integer to return one. Then if you convert this to a false, it returns zero, right? So as we continue to go in data analysis, in most cases we'll come to do true and false. You see a lot of true and falses, right? That Python will use to filter people out. So if you have made the condition is true, if you've not made it's false, right? That's in filtering. People who are used to data analysis, you understand what I mean by filtering. But if you're not, please just stay with me. We're getting there. I'm going to have a special class on that. So int this gives us this guy. So I was just trying to buttress the fact that these guys represent true or false, right? And you also use them to show some certain things, like we saw in our book. We were trying to say, okay, game is active, true, can edit, false. Now imagine you are trying to share a Google document to somebody. There are different levels of access. You have the editor, you have the viewer, right? So if you tell the person can view, true, can edit, false. So the person can only view but cannot edit. If you say can edit, true, it means that the person can what? Can edit. Beautiful. So you have your first set of tasks here to carry out, and then we have our if statements. Of course, we've already done something like this, and I've explained this already. So this is the anatomy of the if statements. Now we are going to talk about now how the if statements work. So you have the if condition, and then you have your conditional test here. The conditional test is what checks, is this number equal to this, greater than this, is it in this list? It checks, and I told you what happens. It returns a true or a false, right? And then depending on it, the if it returns a true, then this something will be done, right? Do something. If it returns a false, it skips. If it has an else statement, then it carries out that else part. If not, it will just skip. It has finished running the program, right? Now, that leads me to the next one, which is the if else statement, right? Now, you can see here, if age is greater or equal to 18, which is not here, right? It will run this guy, right? So here we have our else statement, which returns a feedback telling the person, sorry, you cannot restart this time, right? Now, that is a very good use case of the if else statement. Now, the last one, which is when you have multiple conditions, let me put it that way. You have multiple conditions to check. Let's say we want to build um, a grid prediction system. I'm not going to use this example. So we want to check. We have so many conditions to check. We want to check if the person's. We don't want to just classify it into pass or fail. We can actually do this. You can actually just come here and then collect your score. Let's say your score is 55. You can actually come here and say if score is greater than, I think 40 is the pass mark. Let's take 40 as the pass mark. Is If it's greater than or equal to 40, that means it starts from 40, right? So what do you do? Print what pass. You can decide to just do this, right? And then here it will tell the person pass. So what if the person gets 39? It does not do anything. That's where the else statement comes. Else would tell the person what? Tell the person fail. Okay, great. So tell the person fail. So now, what if we don't want to just do pass and fail? What if we want to write like a grading system that will grade you according to your score A, B, C, D, E down to F, right? We can actually do that with the help of Python, right? So at this point, I will just ask you to. I know you've been enjoying the video. No need to ask. I know you've been enjoying the video. So just smash that like button, right? And then you can also do well to comment. It goes a long way for us. Please do that for us. Like, comment. If you have other people who you feel this video might help, you can feel free to share with them, right? But we need your like and your comment. It helps us go a long way. Okay, so now what if we want to build a a grading system? This is just to tell us whether we have passed or failed, right? So let's check this. Um, let's try to view this. Let's collect score again. It's equal to, let's say, 55. Now let's do the if first if. So first of all, if score is greater than or equal to 70, right? What happens when score is greater or equal to 70? Print what the grade will be, what? A. That is the grade of the person will be A. So let's check now. If we run this, nothing happens, right? Why? Because the grade is not equal to 70 and is not greater than 70 at the same time. So this condition is not met. This condition is false. So this part of the code will not run. So let's go and add another one. So we can add another block, another condition called the elif, using the elif rather, right? We can add another condition using the elif. So we cannot say what if now is greater than 60, right? So what if it's greater than 60? can come back and print. The grade will not be what? B. Let's run this. Still nothing happens. Why? It checked this condition. This guy is not greater than 70. So this does not work. It comes back here. It tests this guy out. This guy is not greater than 60. So nothing happens. Now, elif, you can add another condition using the elif as many as you can. Right? You can come back here and add greater or equal to, let's say 50. Then we'll print what? Print C. So let's run this and see. Now it returns C for us. Right? It returns C. Right? So you don't, like I told you, you don't need to add the else block. The else block is just that block of code that you add there so that it, okay, this is what happens when every other condition fails. Right? And it's important sometimes, but you don't necessarily need it. There are a few cases where you don't need it, but in most cases sometimes you will need the else block. Right? So should I stop here just because I have my score 55? What if this score is now 45? Nothing happens. So it means I still have to go all the way down. So I have Elif, my score now is greater than or equal to 45, right? Because 45 to 49, I think that's D, right? This is 52. This will check from 50 to 69. This will check from 60 to 69. If this score is satisfied, if score is equal to 70, it will stop running this block, right? But if it is not, then it will go to the next condition and check. If this does not hold, then it will check the next condition, right? That's why if you notice we are dropping them, we are not just dropping them randomly, right? We are going one step downward, right? One step downward, one step downward. Here, 45 to 49, right? So if it is greater than 45, what do we do? To print a D, right? This is a strong pass. Elif score now is greater than or equal to 40, right? That's a weak pass. That's E, right? And finally, now, if you like, you can use the else statement if you like. I wouldn't do that now, but else, because the else now means the score now is below 40, right? That's what we are trying to do. But I will show us, I will just write the code and then I will show us something, right? And how we can fix it. So we can print F. So let's run this now. You can see the score is D. And if I enter your score to be 20, in a F you get. If I enter your score to be 80, you can go ahead and try this for different numbers and see if your code is working correctly. So this works. Now you can see how we're able to apply these multiple other conditions, right? And this works in most real life scenarios. You are going to have more than one if statement to check, so you might want to do the if, checking multiple conditions, right? So the if else also checks for just one condition, right? The else block is just there to tell you, okay, if that condition fails, then what? But if you have multiple conditions, right, you use the if elif then else block. Okay. Um Now the down, let me copy this code. So now the problem now with this code now that we've written is, what if I write this code 1000, and I know it's impossible for a student to get 1000, right? He's still going to give the student E. I want you to be able to tell the student, any person, if you enter a score that is above, you should tell the person, okay, this your, this your number no correct to check am again. So here I want to come and add a condition here. I'll come and add that and, you remember, to cap it, and score now is less or equal to 100. So I'm capping it now, right, between 70 and 100. So this score is greater than or equal to 70, and then it's also what, less or equal to 100, right? So if I do this now, if I enter 1000, now if I run it, what will it tell me? To tell me B. Now you can see that's the problem now. So that's where we need to come in now and do this for all of these guys now. Because let me tell you why it is giving me B. Is because this score now, this condition is not satisfied. Why? Because this number score is greater than or equal to 70, you know, and the score, sorry, yeah, this score is greater than or equal to 71,000, of course, but it's not less than or equal to. 100. So this entire guy will be false, depend because of what? Because of the presence of the and. So at this particular point, this guy will not work. So it will go to 60 and check. So 1000 is greater or equal to 60. So it will still print. So it means you still have to come back now, and do for all of these guys now. Let me just copy this guy now. Come here, paste. Then I'll change this to 60. Then what will I now change this to? This will now be what? 69. And that's the importance of doing this now. So that you add the out of range. Now you're trying to solve a problem, right? So you do that continuously for all of these guys so that your code is robust. But the way we wrote it the first time is actually okay, right? So 50 and what? 59. Now we are manually specifying the we now have what? Okay, let's instead of doing this, let's for this guy, yes, we need 100 is included. For here, what if the person now has 69.5? That's also another problem, right? But we'll fix that. We'll see how to fix that later. So come back here. Um, we have here. So here is no longer 70. It's gonna be what? It's gonna be 45. 45 here to what? 50 to 49, right? And then here is gonna be from 40 to what? 44. Now print E. Now else you want it to print F, right? Now we're just trying to fix problems with our code, right? Now you can see the problem now is that here, even in the 1000, it now came back here. Else is now printing F. So for 1000 now, that is not F. So that's why the else block is not the right block for us to have that, right? So we can come back here, add another elif block. Let me just copy one of these guys, have it here, and we'll specify it as F. V here. We'll specify it as what? As F. So here we'll take it from 0 to what? Greater or equal to 0. 0. It's possible for somebody to get 0 now, right? And less or equal to what? 39 now. And then you print what? Else. Else now it prints F. So now it still prints F now because that is the else. So the else block now, we don't want it. Okay, this is supposed to be F, right? Okay. So here now, I want it to print not F but invalid number, right? Now, if now you can see what printed, right? Because invalid number. Let's add the condition number must be between 0 and 100. That is robust. That is a robust way of writing code, right? Now you can see how from a simple code now that we wrote, we're able to see how our and works, right? I just wanted to take you on this journey to see that every of the things you're learning is not useless as far as this book is concerned, right? Okay, so now if we run this, even if we enter a number now, let's say -5, a negative number, it still tell us an invalid number, right? The number we must enter must be between 0 and 100. So what if we enter 0? Tells us it's an F, right? What if we enter 100? Tells us that it is an E. Now, what if I was saying, what if we have 69.5? Still tell us what number is invalid, which is correct if you want the person to only enter integer. So you can come back here and say number must be an integer between 0 and 100. But your users might not really know what an integer is, right? So the first guy here now needs to be 100. Why? Because that's the maximum number, right? So 0 is included. Sorry, 100 rather is included. Now, for the next condition, we can remove the equal to here and then bring it to less than 70. So this less than 70 will solve our problem because here now we are saying 70 is not included, but anything, even if it's 69.999, is still included in this, and that is correct. 60 is included because it starts from 60, but then 70 is not included. But any other thing between this range, right? So let's run this now and see. You see that it gave the person B correctly. So why don't we go ahead and then fix this for the rest, right? So programming just goes how you think it in your head, right? As a man thinketh in his heart, so is he. That's exactly how programming also works, right? So always look at the upper bound and then just remove the equal to here, right? So we're actually solving problems, right? Less than, then here we have 40, of course. And then this one now, whatever number now you enter 49.5, it will still give you what D, because it is within the range of what 45 to what to less than 50. Of course, that was a lot, right? That was mouthful. Take a deep breath and then follow me. Let's go. Let's change gear now. Let's just round up. I think we're almost rounding up. Using multiple elif blocks, we've seen it. We did not. We just started with using multiple elif blocks, and that works for us, right? Of course, I showed you that you can also omit the else block, and it works fine, right? Except that if all the conditions did not work, then if all the conditions fail to work, nothing happens. Everything just stays silent, right? Just like here, if you come and then you take out a little else statement. Sorry, let's take you out. Yeah. So if you run this and then you have 1,000, nothing happens, right? So you need to know the consequences of whatever it is that you're doing, right? But if we have this now and we have 1,000, like we saw, then the else block comes alive. Then it tells us the number is invalid. So whatever it is that you're doing, it's already calculated, right? So testing multiple if conditions. So you can now see in this case now we have if this, if this, if this. It's not looking like what we did earlier when we had elif, right? So this is not the same as these guys. Sorry, here. So this, let me use this example. This guy here, our example here, our innocent example, very, very innocent example. This guy here is not the same thing as having separate ifs. Now let me show you what having separate ifs it does. Remove this el, just have if statements, right? And then run this. Now you see that it will give you A, B, C, D, E. Why? Because it checked if score is greater or equal to 70. What happens? Okay, should I have done this here? Let me copy this. Add a new code cell here. Paste this. Yeah, let me do Control Z here for this one. Why? Let's do it here. Okay, so let's use this one so that we don't destroy the other example. So here, now what it did is it came here, it checked if score is greater than 70, right? It gives you A. This condition is true because 80 is greater than 70. It picks 80 again, it comes here, it checks because each time it sees an if statement, it takes it as a new block of if statements. Here, you wonder why it just printed A here. It's because this is an entire block of if statements. This is one block. So each time you're starting a new if, it's seeing it as a new block, right? These are additional block, these are additional conditions, right? But this is one if block. If you decide now to use separate ifs, it means you're telling it, oh, well, these are the conditions you have to check with different set of conditions. So this is one set of condition, another one, another one. So you're giving it how many different set of conditions, and so it will check these ones one after the other, and each one that that meets, right? Uh, if this condition is met, it carries out that operation, right? Which in this case is just printing the grade. So 80 is greater than 70, giving us grade A. 80 is greater than 60, giving us grade B. 80 is greater than 50. So it will give us, as long as this condition is met, it will still be working, right? So this is very, very different from this. And then does this work? Yes. This right here is possible and it's allowable. And it even happens. There are times where you want to check, several conditions, When I mean several conditions, you want to check several situations, right? You want to check, okay, is the gender male? Okay, is the age greater than this? You want to check them differently, right? But then there is this case where it's the same block of, it's the same situation we are looking at, but then it has several conditions. So it is depending on the use case. But all of these guys are applicable. It depends on the use case you're trying to, use. But if you mistakenly try to achieve this goal and then you use this guy, this is what you're going to get now. Because it will be evaluating all of these guys for each condition that meets. Ehen. But maybe if you try this in this case, if you try it, you're not going to get the same result. Why? Because you are capping these guys, right? Anyway, I'm just trying to show you that this is different from what from this, and hope you understand. If you don't, please drop a message on the, just drop a comment, and I will come help you out on that. Okay, I keep coming back to the drawing board. Our notebook. So we have tested for multiple conditions, right? You can also go back and then check. So this is our exercise 5.7. Yeah. So using if statements with lists, right? So I think we've seen part of this. We're just going to look at how it actually, you remember when we did if this is this, for this in this, do this. We actually saw this kind of example. So I would just want you to, I'll just explain this example and I'll need you to try it out. So this is for pizza, right? I told you to read the example. I already know this is a pizza um, example. And for the pizza, we have toppings. I'm not a very good fan of pizza, but I know in pizza we have several toppings. We have green peppers, extra cheese, mushrooms. I'm not even aware that they used to add mushrooms, right? Not very, very aware of that. But then, if you do, these are the requested toppings. That is the what the customer is requesting. Okay, so these are the requested toppings. So you're trying to tell the customer now for requested topping in top for this for item that is for requested topping in requested toppings. Look at it very well, right? Print adding this guy, right? So it is adding that guy. Now, what if we run out of pepper, right? What if we run out of green pepper? So we want to add a condition. If the requested topping is equals to green pepper, we just tell the person without green pepper, right? Else, we'll just bring adding requested topping. So if you look at this guy now, if you run this example, see the output here. It's going to add mushroom. When it gets to green pepper, it will tell the person, no vex, we'll not get green pepper, but we'll add extra cheese for you. Yeah, so that's what happens. It's just a similar example to what we saw there, right? Where we tried the BMW example. If name is equal to BMW, use dot upper, right? Else use dot title, right? So here is for us to check that the list is not empty, right? So if you just that's another thing again about if statements. So if a list is empty, if you just come here and you do if let's create this name. If names is equal to okay, guest. I think we still have our guest list. Let me check. Yeah, correct. So that our guest. Now we can just do if guests. So print we have invited, you know, have invited, oh, let's say your guest list is ready, right? So look at this now. If guest, so what this guest does, I know we spoke that here it actually checks if it is true or false. So at this particular point, Python still checks this guy. What it does, if you just pass in a list or an iterable, it checks if the list is empty or not. So if it is empty, it returns false. If it is not empty, it returns true. So this guy will run here because guest is not empty. Okay, so let's use this empty list here that we have. I don't want to override this guest list. So let's come here, put my my list. If my list, right? So if this list is empty, you can see nothing happens because my list is empty. So it returned false, right? That is how to check if a list is empty, right? You can use the if condition to check if the list is empty. So if you use the if, you just pass in the list. Just the if and the list. Once you do that, Python automatically helps you check if the list is empty or not. Right? Very good. You can see the advantage of using a book. You might never hear that from a normal YouTube tutorial, right? That's why I like using books. So using multiple lists now is when, for example, now I want you to go and study this example. It's similar to what I'm going to explain now. Now let's say we have let me just quickly create two lists, right? Admitted, this is another example. That is the list of people who were admitted, students who were admitted in the program. I think I have a Muhammad here. I have Divine. Of course, I have Fawaz, the troubling Fawaz. I have Sani. I have Gloria, I think. I hope I do. So these are, let's assume this is the list of the admitted people. So this is the list. I just printed it out now, right? So now, what if you have another list? Those who have submitted their assignments, right? So let's call them uh, submitted assignments. Hope I got the spellings right. Okay, submitted assignments. So this is the list of people who have submitted their assignments already, right? So we have Muhammad, then we have Fawaz. Let's say these are the only guys who have submitted their assignments already, right? So we have two lists here. It's just they're just trying to give us some examples to see how the skills we have learned so far are very, very useful. So let's say I want to get, you know, I want to get a list of students who are yet to submit their assignments. So I want to, I want to print. I can come here and do for uh for students in admitted, right? Let me print, right? Oh, sorry. Let me print the students. So you print the students of the list of students in what in admitted. Now I want to add the if statement. Now I want to add the if I want to print the list of those who are yet to submit. So if the student now, right? If the student now is not in submitted assignments, it means that the person did not submit the assignment. That is what it means, right? So if student not in submitted assignments, right? So we do this. Student not in submitted assignments. Print this. Else, print what? Sorry. Okay, yeah, print the student. Else, you just pass. Oh, we can just leave it man like that, right? We were able to print out students who are yet to submit the assignments. And when we send you email reminders, which I think I will start doing that by tomorrow's evening. When we do that, that's exactly how we do. That's why you notice that immediately you submit your assignment, when the next set of reminder is coming, you don't get reminded because it automatically comes back. Let's assume now someone comes back now. Let's say Gloria submitted her. So let's run now. You find out that it's only Divine now and Sunny that are left to submit the assignments, right? So that's how we also use to find people who are here to submit the assignments, right? I'm just trying to give you a very, very good use case. Beautiful. Now, um, what if I want this in a list, right? I can, if I want to get a list of those who have not submitted the assignments. Um, okay, so I can just create a list. Let me call the list not submitted. Just list up here, not submitted. So I can use the list comprehension if you want them in a list. If you just don't want to print them, you can come back here and then not submitted. You can come back here and do is equal to student or name if you want for students in admitted. That is for all admitted students, right? Student. It will print the student. It will add the student, right? For each student in what in admitted, right? But this time around, we that's not just what we want to do. We want to add a condition if what student if student is not in more like this exactly what is here that I'm copying. It's exactly what is there that I'm copying. Submitted. Let me check if I got the name correct. Assignments. So there's only one way to find out if this is correct, right? So you can see everything is in one line now. course, it gave me divine answer, and I've created a list now. So I've created a list of students that are in here that are not here. Right? I don't know if I made. I don't know if I created clarifications more than confusions. But in case if you don't understand, just take, like I said, rewind the video backwards, and you should be able to get that in. Okay, rounding up. Study the example. Like I said, you have these exercises to carry out. Right now, styling your codes. That's where we always end, right? They teach you how to properly style your codes, right? It's not just about writing codes that work, but style them. Now you can see here, they said this guy here is better than this guy, right? So always give spaces, and you'll find out that when I run my codes here, you'll find out that I always between my operators, I always give spaces. Even if you remove the spaces, this guy still works. But it's better if you have, those spaces there. They increase, they enhance readability, right? So that's that's here they will just tell you to go back and revise your programs and then address your codes, write them properly. Yes, guys, if you're here, take a deep sigh of relief. We're done. That is how far we can go on our today's program. Yeah, today you learned a lot, right? You just added if statements to what you knew. Every other thing else today you knew them. You just added if statements today to what you used to know. And maybe, possibly, you learned how Python used to evaluate statements, right? And pretty much that's just what you learned today. So, of course, if you're still watching this video and you've not liked, if you've not commented, please, I ask now that you go and do that. It goes a long way. It gives us feedback. If there's any concept you don't understand or you feel we should have explained better, do well to hit the comment box. We like that. If you want us to, if you want to join our academy, please do well to drop a comment. We also like to hear from you. For now, that will be all, right? And next class, we'll learn about dictionaries. Yay, dictionaries. I like dictionaries. That's also another structure. They are like lists, but of course, let me not give you more than you should chew. So next week, we look at dictionaries. Very, very fantastic structures. Don't miss the lesson on dictionaries. See you next class.